Hello everybody and welcome to example 5 from topic 3 lesson 4, another exciting example using division of polynomials, the idea of the remainder theorem and the idea of the factor theorem. So in this we're going to check to see if x minus a is indeed a factor of the polynomial p of x. And in previous lessons we've learned how to factor quadratics, but we have not seen how to factor polynomials with degrees higher than 2. So this is one way that we can look at it. This is one way that we can determine if something is a factor of that polynomial. All right, so it says, how can you use the remainder of factor theorems to determine whether the given binomial is a factor of the polynomial p of x? If it is a factor, write the polynomial in factored form. So let's go to my handy-dandy notebook here. And let's, make sure that my degrees in my polynomial count down. We want to make sure that we don't need to have a placeholder here. So we have x to the 4, to the 3, 2, 1, and again x to the 0, but that's just 1, so we don't actually write it in. Okay, the next thing I'm going to do is I'm going to get my value that I'm going to multiply through here, and then I'm going to do my coefficients. So we have 1, -8, 16, -23, and 6. I have a pre-drawn line here, and so what we're going to do is we're just going to start our synthetic division. So I'm going to pull this 1 down below the line. 1 times 6 is going to be 6. Add going down, -8. Plus 6 is going to be -2. -2 times 6 is -12. 16 minus 12 is going to give us 4. 4 times 6 is 24. -23 plus 24 is going to be 1. 1 times, this is a -6 here. 1 times 6 is going to be 6. -6 plus 6 is going to be 0. We have a remainder of 0. So since r of x is equal to 0, capital R of x, then we do have a factor. So x minus 6 is a factor. So the two factors we're looking at. Remember now this is 1x squared, not x squared, I got a little bit ahead of myself, x squared, x cubed. So I'm going to multiply each of these. These are now our new coefficients. So we're going to have x cubed minus 2x squared plus 4x plus 1 times the factor x minus 6. And I wrote this in factored form. Right, so there we have it. We do have a factor. It is a remainder. Writing it in factored form is like that. Okay, the second part, how can you use the remainder theorem or factor theorem? Let's see if this is truly a factor. All right, and let's move this up. Again, draw my line here, just because I'm horrible at drawing lines, as you've seen on this computer. All right, so again, in my mind, I'm just changing that sign to -3. I'm going to make sure I don't need any placeholders, so 5, and we do, so it goes 5 to 3, so we're going to have a 0x to the 4th in between them. 3, 2, 1, and 0, so we have 1, 0, -5, 9, -1, and 3. Again, we need that placeholder for the x to the 4th place here. Pull down the 1. 1 times -3 is -3, so then again 0 plus a -3 is a -3. -3 times -3 is +9. We'll get a 4 here. 4 times -3 is going to be a -12. So I believe that's going to be a -3 here. -3 times -3 is 9. 9 minus 1 is 8. 8 times -3 is going to mean -24. And then we get -19. No, -21. Why I went to 19 is I don't know. We do have a remainder in this case, so let's go double check. And since we do have a remainder, x plus 3 is not a factor of this polynomial. So because negative 3 is not a 0 p of x, you can use the factor theorem to conclude that x plus 3 is not a factor of p of x. So let's look at the common error. When using synthetic division, remember to include 0 coefficients for any missing term. So again, remember to have that placeholder. All right, so here we have one that does not need a placeholder. Oh, none of those need placeholders. So you're pretty okay with this try it. 3, 2, 1, yeah. So go and do the try it, figure out if they are a factor, which basically means, again, you don't have a 0, or you have a 0 remainder. If your remainder is 0, it is a factor of the polynomial. So determine whether the given polynomial is a factor. And we will catch you in the next video. Actually, let's look at the, what's another way to try it. The concept summaries. Make sure that you are taking these into your notes, into your account, the long division and synthetic division, and we are done with dividing polynomials. I will catch you guys in the next video.